You are listening to The Vocal Technologist. Spoken tech for your ears.
Welcome to the deep dive. So today we're looking at a pretty dense stack of tech industry newsletters from, well, mid-June 2026.
Lots of ground to cover this week.
Yeah, totally. And our mission today is to really help you understand what I can only describe as a terrifying but also exhilarating reality. The tools that built the internet are, they're suddenly building themselves.
Which is a massive shift. I mean, we are witnessing the end of an era where a developer's value was strictly tied to memorizing syntax.
Right. So whether you are a seasoned software engineer pushing code every day, or just someone who is insanely curious about how the digital world operates, you really need to understand this tectonic shift. Because AI is fundamentally changing what it means to actually write code.
It's impacting everything. Multi-billion-dollar acquisitions, global cybersecurity, even the basic architecture of the web you use every morning.
Okay, so let's unpack this, because the sources point to this really fascinating piece of research from Anthropic regarding what they're calling agentic coding.
Right, the agentic coding paper.
Yeah. And they've mapped out this brand new, very strict division of labor. Basically, humans are now making the vast majority of the high-level planning decisions, while the AI handles the actual, keystroke by keystroke technical execution.
And that separation of duties completely changes the profile of who gets to be a builder. I mean, it used to be that if you couldn't write a for loop in Python or configure a database, your ideas were basically stuck on a whiteboard.
Right, you were blocked.
Exactly. But now the AI knows the programming language perfectly.
I was thinking about it like this. It's like we are all moving from being the line cooks who meticulously chop the onions and measure the spices to being the head chef who just designs the menu and tastes the final dish.
That's a great way to put it. The AI is doing the chopping at light speed.
Yeah, and zero tears from the onions.
Right. Which means success in this new agentic coding model, it depends so much more on a user's domain expertise. The bottleneck is no longer your formal programming skill.
Wait, so what is the bottleneck then?
Well, it's knowing what the software actually needs to accomplish for the business. I mean, this is why we are seeing professionals in entirely non-technical fields, biologists, accountants, lawyers. They are spinning up software tools that perform at the level of a mid-weight software engineer.
Because they actually understand the problem they're trying to solve.
Exactly. They know the domain inside and out, and they just, describe the house to the hammer.
And if you want to know how seriously the tech industry is taking that exact shift, you just have to look at the money moving around this week. I mean, SpaceX has just locked in a $60 billion all-stock deal to acquire AnySphere.
Wow. AnySphere, the startup behind the AI coding agent Cursor.
Yes, $60 billion. To put that in perspective for you, that is the GDP of a small country just dropped by a hardware-heavy aerospace company to buy a software coding agent.
Which is wild when you really think about it.
It is, and the explicit goal here is to close the gap with OpenAI and Anthropic and to inject that coding capability directly into xAI's Grok model.
Because Cursor essentially sits right inside a developer's environment, right? Reads their entire code base and just anticipates what needs to be built next.
Exactly. So when a company like SpaceX decides that kind of tool is worth $60 billion, the era of the human line cook is officially over.
It is. But, and this is but it also introduces a massive structural vulnerability.
Oh, for sure.
Because if the human is no longer writing the code line by line, and the AI is generating entire modules in seconds, the code itself becomes almost like a byproduct. The industry is realizing they have to stop obsessing over individual lines of code and shift entirely to managing system reliability.
I'm struggling to buy this, though. I mean, I hear you, but if AI writes an entire application in 3 seconds, but then it takes a human engineer 3 hours to read through it line by line to catch, subtle hallucinations, haven't we just made the developer's job incredibly tedious?
You're saying we're turning them into proofreaders?
Yes. We are essentially turning brilliant engineers into full-time proofreaders. Rewriting code might be cheap now, but human manual review has just become insanely expensive.
Well, you've hit on the absolute central crisis of the current software cycle. You cannot review AI output the same way you review human output.
Why not? Code is code, isn't it?
Not exactly. because AI is inherently non-deterministic.
Mm-hmm.
If you give a human engineer a specific bug to fix, they will generally use the same logical path to fix it every single time.
Okay, that makes sense.
But if you give an AI agent the exact same prompt twice, you might get two entirely different architectures back.
Right. It's like a calculator that gives you 4 one day and a dozen the next.
Exactly, which totally breaks traditional deterministic testing pipelines. Our sources highlight how companies like WorkOS are building entire evaluation systems specifically for these non-deterministic tools.
Oh, I read about that. They are deploying their command line interface agents like those text-based bots that navigate computer systems against real complex project directories.
Right, and they do this because AI has a really nasty habit of hallucinating programming methods that sound highly plausible, but they simply do not exist in that specific code base.
Right. It's just confidently making things up.
Yeah, and you can't just read the code to catch that. You have to evaluate the agent's behavior in a simulated space.
And that leads to a really elegant solution from a tool mentioned in the sources, this thing called Greptile's TREX.
Yes, the execution as review model.
Exactly. They are solving your expensive proofreader problem by using execution as the review itself. So instead of using static analysis, which is basically just a program reading the text of the code looking for known errors, TREX orchestrates specialized AI agents that actually take the generated code and run it inside isolated sandbox environments.
So it's actually running the program, not just reading the script.
Yes. They execute it, and then they hand the human reviewer real artifacts. We're talking actual screenshots of the interface, live application logs, memory usage stats.
They were essentially replacing code review with behavior review, which is huge. But adapting to this new reality requires that kind of structural tooling. You cannot just yell at your engineering team to, review faster.
Right, work harder, proofread faster. It doesn't work.
No, you need automated systems that execute and verify. But building that requires strong leadership and an organizational culture that values discipline over pure speed.
Which perfectly brings us to a really startling report in the newsletters about what happens when an organization just completely abandons that discipline.
Are you talking about the meta situation?
Yeah, the meta crisis. They are allegedly destroying their historically strong engineering culture by aggressively forcing AI adoption over basically everything else.
It really reads like a textbook case of organizational misalignment.
It sounds chaotic. According to the sources, Meta is forcing these highly paid, brilliant software engineers into basic, tedious data labeling work just to feed their internal AI models.
They're tracking them too.
Yeah. They are heavily tracking employee activity metrics and literally tying performance reviews directly to how much internal AI tooling the engineers use, regardless of whether those tools actually make sense for the project they are working on.
And stripping away that kind of engineering autonomy has severe consequences. The sources note a massive drop in morale and significant talent flight from the company.
People are just leaving.
Yeah. But most alarmingly, prioritizing AI speed over structural discipline caused a major reliability failure. They experienced a high-profile Instagram account takeover incident.
Wait, that was linked to AI.
Directly linked.
Wow.
That breach was tied to AI-generated code that simply wasn't given sufficient review or sandboxing before being pushed live to billions of users.
Wow. So it's the automated hammer swinging itself and taking out a load-bearing wall.
Exactly.
But I want to contrast that kind of metric-chasing chaos with what happens when engineers actually use good, disciplined system design. Because the sources highlight 2 brilliant examples of human engineering this week. First, this developer who managed to speed up their Go test suites by 2 times using this clever database trick.
Oh, the SQL migration hashing. This is such a brilliant systems approach.
It really is. So usually running a software test means building a database from scratch, brick by brick, running thousands of individual changes, which are called SQL migrations, just serially, one after the other.
Which is incredibly slow.
Painfully slow. So instead, this developer used hashing, which basically creates a unique digital fingerprint for the final fully built database.
So they don't have to build it every time.
Right. Now, before running a test, the system checks the fingerprint. If it recognizes it, it skips the construction phase entirely and just instantly photocopies the existing database using a backup API.
I love that. They optimize the environment rather than the code itself.
Exactly. And then there's a second example, Timescale DB. They achieved up to 98% compression for time series data inside PostgreSQL using their hypercore engine.
98% is massive.
I know. They did this using specific algorithms like Gorilla XOR and run length encoding.
Which I admit sounds incredibly dense, but the concept is actually quite elegant.
Right. Think of it like this for you listening. If you are trapping the temperature of a server every second and it stays at 70 degrees for a solid hour, traditional databases basically write down the number 70 3,600 times.
Just wasting space.
Totally. But these algorithms look for patterns and differences instead. So run length encoding just says the number is 70, repeat it 3,600 times.
And what about the Gorilla XOR?
Gorilla XOR looks at the deltas, the tiny changes between numbers rather than the whole number itself. By applying this logic to batches of 1,000 rows at a time, they shrink massive data sets down to almost nothing.
So brilliant tooling can compress data and optimize environments. That's the human element shining through. But, and here's the darker side, all of this highly optimized AI-generated infrastructure creates a massive centralized target.
Right.
If AI is rapidly building our systems, what happens when advanced AI is weaponized to attack them?
And that is the exact intersection causing huge international drama this week. And I want to be very clear with you listening right now. We are looking at a highly controversial geopolitical event here. We are not taking sides. We are not endorsing a viewpoint. We are strictly reporting the arguments laid out in the source material.
Right. We are simply analyzing the dynamic between regulation and capability.
So the United States government recently invoked Export Control Authority to forcefully shut down Anthropic's advanced AI models, specifically the ones known as Mythos 5 and Fable.
And the government's stated justification for this unilateral action was that these models pose severe security risks. They argue the models could be used to discover zero-day vulnerabilities in critical infrastructure.
On the other hand, many prominent cybersecurity experts quoted in our sources are pushing back hard. They are calling the government's action short-sighted and even reckless.
Because their argument is that defense requires parity with the offense.
Right.
These experts argue that advanced models are necessary tools for cybersecurity defenders. They need them to proactively identify and patch vulnerabilities before bad actors can exploit them.
And the sources argue that shutting these models down domestically doesn't actually make the world safer. It just deprives local developers and local companies of defensive resources, especially while international labs, outside of U.S. jurisdiction, continue to release comparable or even superior AI capabilities.
And there is empirical data in the sources supporting the defensive power of these models, too.
Oh, the Triaging Council study.
Yes. A recent study put together a triaging council made up of 4 different advanced large language models to evaluate software vulnerabilities. And that AI council achieved an impressive 86.2% unanimous agreement on identifying and triaging security threats.
Which is wild.
Yeah.
It strongly suggests that higher reasoning models are highly effective at fortifying systems.
Exactly. And in response to the government shutdown, Anthropic is pivoting its strategy. They are adopting much stricter data policies to align their commercial interests with internal control mechanisms.
They are essentially trying to prove to regulators that they can internally safeguard these models without needing federal intervention.
Right.
But here is where the narrative takes a really interesting twist. Because while governments are debating the theoretical security risks of superintelligent AI, human hackers are out there exploiting the simplest, most devastating gaps.
The human element will always be the most vulnerable dependency in any network, no matter how good the AI is.
Think about the last time a tech recruiter messaged you on LinkedIn with a job opportunity or a coding challenge. Would you have downloaded their file?
Most people would.
Right. The sources detail a story of a developer who was targeted exactly like this. A fake recruiter reached out on LinkedIn and asked the developer to do a standard code review on a specific GitHub repository as part of a technical interview.
It completely leverages a standard, everyday developer workflow.
That's the insidious part. It feels normal. So the victim cloned the repository and installed the project dependencies so they could read the code locally. But hidden inside those routine dependencies were malicious scripts.
Just waiting to execute.
Exactly. They automatically executed remote payloads, opening a backdoor directly into the developer's machine.
And the psychological manipulation here, the social engineering, was incredibly sophisticated.
Yeah, they didn't just make up a fake name with a stock photo. The hackers used the stolen, verified identities of a real journalist and a real software engineer to build rapport and trust with the victim over several days.
So it wasn't an advanced AI model cracking a cryptographic firewall.
Nope. It was human deception, leveraging a developer's desire to get a new job.
Which brings us right back to why engineering discipline is so critical. You can have an AI that writes perfect, bug-free syntax, and you can have a separate AI that reviews that code in a pristine sandbox environment.
But if a human manually installs a compromised dependency,
Exactly. If a human engineer does that because they were tricked by a fake LinkedIn profile, the entire multi-million-dollar system falls apart instantly.
so what does this level of deception, combined with the sheer speed of AI automation, actually mean for the future? Because according to the newsletters, this isn't just changing how we secure our systems, it is fundamentally altering the architecture of the internet itself.
We are transitioning away from the traditional open web toward what is being called the agentic web.
Yeah, there is a striking thesis in one of the articles that simply states, and I'm quoting here, "The web we know is going to disappear."
It's a bold claim.
It is. The argument is that the old human model of search and click, opening a browser window, typing a query, clicking a blue link, reading a page, that is obsolete.
Right, because we are shifting towards centralized AI interfaces that just give you direct conversational answers.
Exactly. And because of that, websites are transitioning from being human destinations with nice visual layouts into basically just background infrastructure. They exist silently just to feed data to machine learning models.
And the underlying cloud infrastructure is already adapting to support this mass migration. Look at the rise of cloud browsers, specifically companies like Browser Use.
Yeah, what are they doing differently?
Well, they are heavily optimizing their infrastructure, not for human users, but for AI agents. They use Firecracker virtual machines, which are these incredibly lightweight micro VMs, to spin up entirely new, secure browsing sessions in a fraction of a second.
And the cost is just staggering. They operate these agent browsers at just 2 cents per hour.
2 cents?
Right, these are literal bots surfing the web at a massive industrialized scale.
But it goes beyond just scraping websites for data. The sources highlight tools like Nyla's agent accounts.
No, the email thing.
Yeah. Historically, if an AI agent needed to send an email or check a schedule, it had to borrow a human's inbox through a complex, fragile authentication flow. But Nihilus is giving AI agents their own dedicated, hosted email addresses and permanent calendar identities.
So the agent is no longer a guest in your inbox. It is a resident on the web. It can reply to emails, negotiate meeting times, book appointments entirely on its own.
It's an incredible abstraction of daily life.
It really is. But, and I feel like we have to say this, as much as we talk about the abstract, agentic web, I want to bring this all back down to earth for a minute, because no matter how advanced our AI gets, software ultimately has to map to human reality.
And human reality is messy, political, and entirely unpredictable.
Always. The physical world always asserts itself over the digital one, and the sources have the absolute perfect example of this.
The time zone issue.
Yes. So in 2026, the Canadian province of British Columbia is shifting to a permanent UTC-7 time zone offset.
Right, they're ending daylight saving time changes forever by legislative decree.
Right. It seems like a simple real-world law. Good for them, no more changing clocks. But this is causing absolute horror for developers.
Because of the UTC trap in database architecture.
Exactly. An AI agent can write flawless PostgreSQL syntax in a second, but it doesn't know that humans just voted to change the definition of noon.
It has no context for the physical world.
Right, and here's how it breaks. Developers usually store future events, like a dentist appointment, as an absolute point in the universe using UTC time.
Which is best practice usually.
Usually, yeah. But if you booked an appointment for 2027 last year, the database converted your local time to UTC based on the old time zone rules.
Ah, I see where this is going.
Yeah. When the government suddenly updates the local time rules in 2026, every single absolute UTC point stored in that database for British Columbia is now wrong by exactly 1 hour when converted back to a user's wall clock time.
The code operated exactly as it was designed to. It was perfect, but the reality shifted underneath it.
Exactly.
It is such a humbling reminder that whether it's AI generating syntax or autonomous agents booking calendar invites, or even international governments regulating advanced models, the physical, messy reality of human life, like what time the sun sets in Vancouver, will always be the ultimate test of our software.
I couldn't agree more. Okay, let's take a breath and recap the massive journey we've been on today. We've explored this wild new era where the human acts as the high-level architect, guiding the AI's rapid technical execution.
We've seen why that speed demands incredibly strict automated code review discipline. So we aren't just turning engineers into proofreaders.
Right. We navigated the intense global security debates over powerful AI models and the enduring threat of human social engineering. And finally, we looked at how the open web is slowly transforming into a background playground for autonomous bots.
It is a profound amount of information, but it all points to a singular, undeniable shift in our relationship with technology. We are no longer just using tools, we are managing automated workers.
We absolutely are. And before we wrap up, I want to connect back to a concept mentioned in the sources called the dialogue dividend.
I love this concept.
Me too. The idea is that having conversations introduces a real-time feedback loop. It refines our thoughts far better than just sitting and thinking in solitude. Our hope is that this deep dive serves as that conversation starter for you listening, sparking your own curiosity and refining how you approach your own work in this new landscape.
And on that note, I will leave you with a final thought to mull over. We've seen today that AI agents are now getting their own permanent email addresses, and that human-facing websites are slowly becoming just background infrastructure for machine learning to parse.
Yeah.
So the question is, will there come a day when AI agents start building user interfaces exclusively for other AI agents to consume, completely abandoning human readability altogether?
Wow. Think about that the next time you're describing that house to the hammer. Thanks for joining us on the deep dive.
Spoken Tech for your ears.